All right, so we are back in Algebra 2. Today's date is Tuesday, September 24th, 9/24/19. We are talking about complex numbers. The cards have been passed out with your quiet raised hand, with your participation card, except Ellery and Beverly should have their participation card in from doing the warm-up. Quiet raised hand, who can read the objective for today? Who can read? Caroline can do it again. She's so fast.
Classify parts of complex numbers and graph them on the complex.
There it is. There's 2 parts to the objective, yet there are 3 homework assignments because 2 of those homework assignments are so easy to do. All right, so here we go. Parts of the complex number. I call this thing rectangular form. Write it out. This thing is in... I cannot...
How much AP do you get for reading that?
50 for participating.
Oh, wow. That's a lot.
Rectangular form. This is in rectangular form. You will never learn polar form when you're in Algebra 2. I don't think, at least. You'll learn polar form later when you are in pre-calc next year. But this is in rectangular form where I have a real. Let's all label this. This is the real. And then the B, not the I, just the B is the imaginary.
Wait, why is the I the imaginary?
I mean, technically, BI is the imaginary part, but B is what you're looking for if you're talking what is the imaginary part. It's the B. Like how far up and down to go, you're talking about the imaginary part. I mean, you can make the argument that BI is imaginary. It might make things harder down the road, but yeah, you're fine. All right, so add your real, add your imaginary. If you do it in this form, it's really easy to do the conjugate and a bunch of other stuff where you do real, then imaginary. Nod your heads. Real, then imaginary. You understand? Nod your heads. Chewy hood. All right, so from here, I'm going to tell you about the hidden shadow and dimension. You have been in here your whole life. Real numbers. You had irrational numbers. And I'm going to need a quiet raised hand. Chewy hood.
Oh, sorry.
I need a quiet raised hand to tell me an example of each of these different domains. Can someone give me an example with a quiet raised hand? A whole number. Nice and easy. A whole number. Does anyone have a card? Anyone has a card? Oh, Colby has his card, yeah. 2. Write it down. 2 is a whole number. That's also an integer. That's also a rational number. That's also a real number, which is also a complex number. You didn't even know it before, but 2 is a complex number. All right, so next up, integers. Someone give me an integer. And give me specifically an integer that is not a whole number, because you could say 2 is an integer, 2 is a rational number, 2 is a real number, but that's not helping us any. Ellery, your card should already be in, I think, from the warm-up.
No, it didn't.
Oh, she did? Oh, Ellery, go for it.
-3?
-3 is an integer, yet it is not what I would consider to be a whole number. Whole numbers are counting numbers. I don't really count backwards. So -3 is an integer. Thank you. And you give yourself 50 XP. A rational number. Who can give me a quiet raised hand for a rational number? Rational. Think fraction. Rational, ratio, fraction. A half. There we go. A half is a rational number. Can anyone give me an irrational number? You should know at least one of them. One is very famous. Any cards? No cards? India?
5.
Phi?
Yeah.
Oh, man. Phi. I love phi so much. Phi is the best number.
Why?
And that's not even like an opinion. I think it's a fact. It's like the best number.
Why?
Phi is the golden ratio. If you look at humans or anything in nature that has a ratio that's really, really close to phi, then you consider it to be beautiful. It's what we as humans consider to be beautiful. So it is the most beautiful number.
Is 0 the line? Yep, I don't have that.
Phi, right up there. And I know that people get mad when I say this, but I can take a picture of your face like a, what do they call that when you're doing your mugshot? A mugshot of your face, and I can run a program and I can tell you how close to phi you are and mathematically calculate how pretty your face is, in quotes, in air quotes. I could, yeah. In fact, the person, okay, I need to look this up. There was a woman in
Why are you late?
Europe, I don't remember where in Europe, but somewhere in Europe had like a most beautiful portrait, and they ran her image through the program, and it was like, yeah, she basically has phi everywhere.
Can you show us?
Can someone remind me at the end of class, because this is going to be a tangent that's going to take me at least 5 minutes.
No.
But know that phi is an irrational number. Also, pi is an irrational number. E is an irrational number. Those things that are transcendental numbers that don't repeat their digits and go on and on and on forever. Give me a real number.
7.
Yeah, a real number is a combination of a rational number and an irrational number. So you can do things like anything that's in those groups. I'm not even going to do an example, but yeah, 7 would be a whole number and an integer and a rational number and a real number and a complex number. But here's a complex number, 3 plus I. 3 plus I is a complex number because now all of a sudden I have an imaginary part. But I'll say this again. E, this number pi is both an irrational number, it's a real number, and it's a complex number. Pi is a complex number. 2 is a complex number. 3 plus I is also a complex number, but 3 plus I is not a real number. Nod your heads. We're awake. Okay. I'll give you an example of something that's purely imaginary. 3i. And I'll do an arrow here. Purely imaginary, 3i is purely imaginary. It does not have any real part. This a from our imaginary or our complex number is missing, so it's purely imaginary, not real. Is that a question?
Oh.
Yeah.
Yes. Why is 3i imaginary but 3 plus I is not?
3 plus I is complex, but it's not purely imaginary. So to be purely imaginary, you can have no real part and only this part.
Oh, so when it's time. Okay. Okay.
All right, so when I use a number z from here on out, assume that z is a complex number, which basically is saying nothing because everything that you've ever learned is already a complex number. But now that we know that we're in complex land, the shadow dimension, we know what we're doing. Okay, so example 1. This is one entire homework assignment. It's this easy. Tell me what the real part of z is. Quiet raised hand. What is the real part of z? Someone that has their card. Oh yeah, you don't have your card. Lorea? 6. It's that easy. Thank you. 50 XP. 6 is the real part. Who can tell me what the imaginary part is? Do you have a card?
Yeah.
Jaden.
4i.
Careful.
Oh, wait.
It's not including the I, and it's
wait, what's it? 4.
careful.
I.
Careful.
I4.
No.
Negative 4.
There it is. Thank you.
Okay, we don't carry information.
Jaden, that's so disrespectful.
How is that disrespectful? You didn't raise your hand. But if I were to shout something out, you would take HP off.
That is a good point.
Thank you.
Next time I'll deduct HP from both. All right, so example number 2. This is one entire homework assignment. I think you guys can understand how to get the imaginary part and how to get the real part. It's that easy. I'm not going to spend any more time on it. Let's talk about this one. These guys are notoriously trick questions. Be careful. What type of number is 104i minus 33.24? And you're choosing all answers that apply. So think about it to yourself. Is it A and B, A, B, and C, just B, just A? What is it?
Is this one the homework?
This is going to be an entirely new homework assignment for example 2. Now talk to your neighbor. Did they get it right? Talk to your neighbor. Left and right. All right, quiet raised hand. What's the answer? Quiet raised hand. What is the answer? There's only one person that knows what the answer is. 2 people have an idea. 3 people. Quiet raised hand. Anyone else? Oscar, do you have your card still?
Yeah.
Can you raise your hand with your card too? Yes, Oscar. Tell me, what did you get?
I got pure imaginary.
Pure imaginary. You still get your 50 XP because you participated, but that is not quite right.
Yes.
If it was pure imaginary, I would have no real part. So 104i is pure imaginary, but 104i minus 33.24 is not pure imaginary. Can someone else help Oscar out? Cheyenne.
It's complex.
It is indeed complex, Cheyenne. All right.
Wait, is it?
Leo, stop.
Oh, wait.
That's being disrespectful. You know it.
So that provoked me.
Don't be provoked. Notice that there's no HP deduction for provoking, but it's still really rude to provoke people.
It's up there. Why isn't it?
I haven't even done anything.
It's up there.
Where is it?
Don't provoke.
Where?
There it is. He's right.
Oh man, that needs to be a new HP preset then.
I didn't even do anything.
Wait, so as of right now, I can provoke all I want?
Pretty much.
Where is Rude? Sam, you're going to protect him, though. And then Leo takes a little bit. All right. All right, let's try another one. What type of number is 78? Choose all answers that apply. I'll give you guys 10 seconds. What type of number is 78? Is it real? Is it pure imaginary? Is it complex? Is it multiple of them? I'll give you a hint here. It's more than just one. Brian.
Real?
It is real, and there it is. Thank you, Brian. It is both A and C. I'll eventually come get your card, or you can pass it around.
What makes it complex again?
Anything is complex. So my default answer for everyone is make sure that C is always chosen because everything is complex. Look at this diagram. Do you have anything that is not in complex land? Do you have anything that's out of the shadow dimension? Everything is contained within complex numbers. Everything that you ever know. Although I could teach you something that is out of here, but it's kind
Wait, yeah, what's not a complex
of
number?
types of infinity. Types of infinity are not complex.
Why aren't they complex but like one is? Because it seems the other way around. It's like one is super
That's a great question. So here's the answer.
complex.
It just means that the imaginary part is 0. 0 is still a number. So if I have an example like this one, come down here to 78. 78 can be rewritten like this. Let's add it to the notes. 78 can be written as 78 plus 0i. Now it's complex, but it's the same thing as 78. The imaginary part is 0. The real part is 78. This is still complex. It just means that your shadow is 0. You don't have a shadow. Are you okay, Leo?
Whoa.
Just broke again.
That is really cool to think about.
Whoa.
It has no shadow.
Oh my god, math.
Math is cool, isn't it?
I know it is.
All right. Let's move on. Let's erase this. It casts no shadow. All right, so we are on to the back. So the first half of our objective should be met now. Classify parts of complex numbers. Let me get a fist of 5 before I move on. Classify parts of complex numbers. The first half of our objective. Can't speak. Where are we? Chewy. There it is. I see 5s, 4s. Give me a fist of 5. Everyone, how well can you classify parts of complex numbers? Is that a 2 for Sam?
Yes.
Do you have a question, Sam, that I can clarify? 3. Everything? Okay, I can come work with you for the homework. You and Oscar. We're plotting complex numbers. This guy right here, write it down, is called your complex plane. That is the new name. The complex plane, where the old x-axis used to be, is going to be called real numbers. I'm just going to do RE. I guess I can do REAL. Real numbers. The y-axis is no longer the y-axis. It is called imaginary. I have revealed to you this new shadow dimension. You don't just move left and right. You can move up and down as well without just doing a random other real number. Quiet raised hand. What was our old plane called? Does anyone remember what the old plane was called with x and y? Started with a C? India?
Coordinate grid.
A coordinate plane, yeah, coordinate. So the old one, you can write it down if you want. You don't have to. This old one was called coordinate plane. But we are no longer dealing with the coordinate plane. We are dealing with the complex plane. There should be an E in there somewhere. Is it a question?
I'm just wondering, if we're working with shadow stuff, are we basically measuring how tall you are, so how long your shadow is? Or whatever?
Kind of. We're going to be doing stuff like that more in pre-calculus. But yeah, eventually we're going to be dealing with like your length of your shadow and stuff like that. It's really your distance from the real axis. But yeah, that's another way of thinking about it. Let's come down here to example number 4. I'm going to plot -6 minus 3i on the complex plane below. I will do that, and then you all will plot -2 plus I on the complex plane. So here I go. -6 is the real number. Please stop. -6 is a real number. So on the real axis, I'm going to move -6. I said stop. And then I'm going to go minus 3 in the imaginary. So the imaginary is going up and down. This is imaginary. So I'm going to go down 3, and there is the point, -6 minus 3i. I have plotted -6 minus 3i. I want you guys now to practice plot -2 plus I. Then check with your neighbors.